Welcome to The Secret Sense, the show that brings you top secret facts about the senses of the human body.
This is Millette.
And this is Jen.
Today's episode focuses on the ear. You know, I wonder if Alan in production realized he ordered us 2 left ears.
I don't think so.
Anyway, the sense of hearing and equilibrium are provided by the inner ear.
Hearing is a response to vibrating air molecules and enables us to detect and interpret sound waves. While the sense of hearing is provided by the inner ear, our focus today is on the equilibrium.
Equilibrium is the sense of motion and balance, and it informs us of the position of our head in space by monitoring rotation, linear acceleration, and gravity.
Simple mechanoreceptors, called hair cells, respond to different stimuli and provide information for the brain. A hair cell contains a single large cilium called kinocilium and numerous stereocilia which resemble long microvilli.
Hair cells do not actively move their kinocilium and stereocilia. Instead, an external stimulus creates force by setting fluid called endophyllum into motion. The hair cells convert the motion into an informative pattern of action potentials. Movement of endolymph in one direction stimulates the hair cell, and movement in the opposite direction inhibits the hair cell.
Equilibrium sensations are provided by the hair cells of the vestibular complex that resides in the inner ear. The vestibular complex is the combination of the semicircular canals in the vestibule.
The semicircular canals enclose a system of 3 semicircular ducts. The anterior, posterior, and lateral semicircular ducts contain sensory hair cell receptors that respond to the rotational movements of the head.
Each duct has an extended region called an ampulla that contains a gelatinous structure called cupula. The cupula contains a region of hair cell receptors known as cristae.
An example of how the semicircular ducts detect rotational movements of the head would be if you were to shake your head no, that's a horizontal rotation, and it would stimulate the hair cells in the lateral semicircular duct. If you were to nod your head yes, it would excite the cells in the anterior semicircular duct, and if you were to tilt your head from side to side, it would excite the hair cells in the posterior semicircular duct.
The vestibule is the second component of the vestibular complex that detects gravity and acceleration. The vestibule consists of 2 membrane sacs, the saccule and the utricle.
Hair cells of the saccule and utricle are clustered in oval structures called maculae. The saccular macula is oriented vertically, and the utricular macula is situated approximately horizontal when the head is upright.
The sensory epithelia of the saccular and utricular maculae convey information about the position of the head with respect to gravity and provide the sensation of linear acceleration. As in the ampulla, the hair cells are embedded in a gelatinous mass. However, in the vestibule, there is a surface of calcium carbonate crystals known as statoconia. The gelatinous mass and statoconia are collectively known as an otolith or earstone.
So it's funny, we're all walking around with rocks in our ears. An example of how the vestibule detects gravity is when your head is in an upright position, the statoconia sit at the top of the macular surface. When your head is tilted, the weight of the statoconia is pushed to one side and it distorts the hair cells. The vestibule also detects linear acceleration. Similar to how gravity is detected, when sudden acceleration is experienced, such as when you ride in a car, the statoconia lag behind, and the effect on the hair cell is similar to tilting your head back, therefore giving you the impression of increasing speed.
Now think about that the next time you step on the gas pedal.
That's all we have today for the inner ear.
Thanks again, folks. Join us again next time for the secret sense of the tongue.
You won't believe what your taste buds can do.